building, you have an application, it's really interesting, everything works, you think, and then basically your customer says, hey, there's a bug somewhere, you need to fix that. So you send in the developer goes to fix the bug, and then, problem solved. And that's a really common scenario in web development or scripting language development, basically development in general. You fix something here and something breaks over there, because there are a lot of dependencies that you can't foresee. Something here might have a lot of influence on something down the line here. So it's really common to, to fix a small problem and get 10 bigger problems in return. Now, the way you can solve that is by applying unit tests. And unit test is basically a way of automatically testing the software that you're writing. Unit tests are basically scripts that test the software on the lowest level. So you write a function that adds 2 numbers, then you write a test that actually checks, if I pass these 2 numbers, do I actually get the right result? Now the thing is that the most important thing here is that it prevents regressions, because if you have a large set of unit tests that test all your software, and you make that little change in the code somewhere, then you can run the test, and basically the test will tell you, hey, by making this small change, you've broken this feature, and this class no longer works, and the unit test will basically tell you. And it saves a lot of time, because especially in large enterprise applications, you can't manually test each function every time you make a change, because there's just too much to do. It takes hours and hours and even days to go through your code. If you have test scripts that do that automatically, it's a lot easier, because you just run the script, you go grab a coffee, and when you get back, you get a report of what's broken. Or if there's nothing broken, then it'll tell you as well. I've made a little list of what products you can use to do unit testing in web applications with scripting languages. And for most languages, there are libraries like this that you can use. I see people writing down the URLs of the things, but I'll share the slides so you don't have to write down the URLs of the products I show. But for every scripting language, there is a library that can help you write these unit tests. The next thing to look at is continuous integration, because when you write these tests and you run them and you go grab a coffee, that takes time. It still takes some time to do the test, and it takes some discipline. If the developer forgets to run the tests, then some bugs might slip in. What continuous integration does, that's basically a set of products that help you automate these tests, or the execution of these tests. With continuous integration, you can make it, you can figure it in such a way that whenever a developer makes a change and commits it to your code repository, then automatically a set of tests is triggered. So automatically, whenever someone makes a change, in the background, somebody or some machine is running all the test cases and will email you if you broke something. So that takes away the requirement of discipline, because you have a system that takes care of this for you. It makes sure that everything is continuously tested. Everything is always tested when there are changes. Cruise control is one of the most popular tools there, and it has plugins for a lot of languages. For example, for PHP, there's PHP Under Control, which is a cruise control plugin that helps do continuous integration on PHP products. But it also supports other languages, because basically it's just a build tool. It's basically a trigger that says, hey, something changed, I need to run the tests. And then present that in nice graphics. What I discussed in the beginning of this topic was that testing happens at the end of the life cycle, so it usually gets skipped if you have a tight deadline. If you want to prevent that, then you can have a look at test-driven development. And test-driven development is basically the tests are leading and no longer the code is leading. So what basically happens in a test-driven development scenario is that you first define your functionality, then you first create a test case. For example, I need to write a function that can add 2 numbers. So what we do is we first write a test case that actually tests if the function works. You run the test, and of course the test fails because you haven't written any software yet. And then what you basically iteratively do is, write software and fix software until your test works. If the test succeeds, you're done. If the test fails, you just continue to refactor. The nice thing is about this is that, testing is no longer done at the end. It's an integral part of your development. Every time you're developing something, you've already written the test. And that makes sure that even if you have a tight deadline, you still have your test and your quality assurance in place. What we see is that test-driven development takes a little bit of extra investment, because you have to write these tests. So it takes a bit more time initially in development, but you save that time further down the line when you're in maintenance. Because if you have these tests and if you are certain that your software has a certain quality, you spend a lot less time on bug fixing. Often if you don't do things like this, then what happens is you run a project and your project takes 4 weeks. And then you go into testing, and it takes another 4 weeks, to get all the bugs out. By doing test-driven development, you can save that time at the end by just, investing a little bit up front and writing those tests. Next step to look at is optimization. You've written your web application, and now you need to look at performance. And again, with our building metaphor, you could have something like this. You have like a 40-story building, and on top there's a restaurant, and every time somebody needs coffee, they need to go, all the way up to get their coffee, and that takes a lot of time. That's basically the same. The solution for that is that, every building has these small coffee corners. You have a restaurant in the top, but you have small coffee corners on each floor where you can just grab your coffee. So you don't have to go up and down all the time. Well, that metaphor is also true for applications, and then we call it caching. A lot of web applications are written in such a way that each time a user visits your website, you're pulling data from a database. And that data isn't really changing all that much. For example, if you have a content management system, the user might, change a page once a week, but you're still pulling the data from the database all the time, and that takes a lot of time. If you implement caching, then you're basically, just skipping the database and taking that data directly from memory. There are several solutions for that. Most frameworks support caching, so if you use a framework, just look at its caching implementation. There are also interesting projects such as Memcache. Memcache is a really cool system that's distributed over multiple servers, and it helps you cache data in memory. It's a lot faster to pull data from memory than it is to pull it from a database. So if you have data that you need to frequently pull from a database, store it in Memcache and your website gets a lot faster. Even with dynamic websites, people say, I can't do caching because my website is dynamic, because I have news item, and the news is like, every 10 minutes I have a new news item. But still, if you look at the ratio, even if you publish a news item every 10 minutes, and within that 10 minutes, hundreds of people will read that news item. So even with dynamic websites, you're still pulling a lot of data from the database, whereas it changes only once in every 10 minutes. And then a product like Memcache can really help you. And Memcache is generic, so you can use it whether you use Ruby or Python or PHP, all of them can talk to Memcache. Another product that's really interesting that we've used recently is Varnish. And Varnish is basically a cache that you put in front of your whole system. And that caches everything from images to HTML, CSS files, snippets of data. You can, for example, say, hey, I have a website here, and this page changes once every week, so I can cache that for a week. But there's a little snippet on there that contains, quote of the day, and that changes every day. Varnish really helps you to identify that, and to Varnish you can say, hey, this part of the website needs to be cached for an hour, and this part needs to be cached for a week. And it's a really fast tool. It works similarly to Squid. Maybe people have used Squid as a reverse proxy. It's just 20, 30, 40 times faster than Squid even. It's a really interesting project to have a look at. Another important topic to look at is deployment. If you write an application using scripting languages like PHP or like Ruby, what happens a lot is you just zip the stuff and send it to the customer. Or you open an FTP connection to your server and you put everything up there. It's really important to bring some structure in that process. And the structure should be that you develop the application. You run your test cases, you test what you've developed. Then you deploy to a staging environment. A lot of people are used to deploying to your live environment directly, but it's really dangerous. If you have like hundreds of users and you make a mistake when you're uploading the code, then something goes wrong and your website goes down. So it's really important to do that to like a staging environment. On the staging environment, you can do acceptance tests. You can have your customer look at the website. This is what we're going to put live in a few hours. Just do a final test on it, and then you deploy to your live environment. If you use SVN for source control or other source control tools that we've discussed earlier, then it's really easy because you no longer have to FTP things, and you no longer have to worry about, did I upload all the files, or I can't override this file because it contains configuration data. There's a lot of complex stuff in there. SVN takes care of that for you, because with SVN you basically put all your software in the source control system, and when you want to go live, you go to your staging environment and you basically say, SVN check out this application, and it will pull all the data from your source control system and install it for you. If you want to update, you just say SVN update, and it will just update all the files that have changed. You no longer have to worry about missing changes or overwriting files. Something that happens a lot with FTP is that it takes an hour to upload the file. So if you do that to your live environment, then half of